Great.
All right. We've got some guys from a long ways who have shown up. We've got some Deutschland here. So, one good person. And I talked to somebody from Amsterdam. There we go.
Brazil?
Brazil, yeah. Makes me feel kind of special, even though I'm sure you're not just here for this.
They heard there was free beer.
That does help to bring people in from Germany in particular. Okay. Now, the presentation I've got for you guys is primarily around just some problems that we run into in cloud and how they're addressed. What I'm going to be looking at are a few specific deployments, primarily customers of SaltStack, and how we use SaltStack there, but also how we use a lot of other technology in some of their infrastructures. But before I dive in, who here has heard of SaltStack before? Wow, seriously? We're running at 40%? I haven't had a room this bad for a year and a half. Okay. I'm in San Francisco. Okay. Who here has a Salt deployment? Okay, we've got well, yeah, you guys are going to talk about it. And of course, everyone in Germany knows about Salt.
Yes.
Okay. Okay. So again, what I want to talk about is a lot of the problems that, and I don't have a ton of time, but some of the problems I should say, that we run into in particular when we're solving problems for companies that go beyond just setting up infrastructure as a service or a platform as a service. Problems that they run into when it comes down to automating more complex routines. Okay? And so I'm basically gonna walk through 3 examples of a few different companies, some of the things that they've done, some of the topologies that they've deployed, and how they've worked out for them, and why they found them beneficial. Okay? We're gonna start by talking a little bit about Wikimedia. Wikimedia's got a really cool infrastructure, as you might imagine. LinkedIn has been using SaltStack for a dangerously long time, back before I would have ever considered it anywhere near LinkedIn worthy. But they solved some pretty complex problems with Salt and again other tools. And then the last one is a job that we're working on right now, which is using a more complex logic engine inside of Salt to solve auto-scaling problems and kind of where we're going with that. So we're somewhat starting with some of our earlier deployments and moving into some of our next generation work. So if we come back and we start looking at Wikimedia, the central problem that they ran into had to do with code deployment. But before I start, let me do a quick, since there's so many people here who don't seem to know about SaltStack and Salt, let me do a quick overview of what Salt is so that it starts to make a little more sense as to what I'm talking about. But SaltStack, what we produce a piece of software, Salt. It's an open source project, and it is a configuration management engine and an automation platform. So it's built on, well, there's a lot of pieces in it. It's made to be an automation system to solve disparate problems. And so the foundation of the platform is a remote execution engine that's very, very fast. And on top of that remote execution system, we have file delivery systems, we have a configuration management system, we have cloud integration tools, we have cloud monitoring and management tools. There's a lot in there. And so as I go through some of these, we're going to highlight some of those components of Salt. It's really this big automation toolkit, and again, as well as a number of other pieces that these companies are using. And so diving back into Wikimedia, that was probably the fastest introduction to Salt I've ever given. But yeah, diving back into these guys. Yeah, I got applause. From Nintendo Man. Killer t-shirt. What?
$7 at Target.
$7. I know it's on a camera, it's gonna go online. You work for Target? Okay. So the problem that Wikimedia was facing was around code delivery. Now, one of the reasons that I really like to talk about Wikimedia is because they don't use Salt for configuration management for this particular deployment. They have a ton of Puppet code in-house, as you can go and view. It's all open. You can go and see all the Puppet code that Wikimedia uses to deploy Wikipedia. But what they ran into is that they wanted a system that they could do continuous code delivery with. And so the problems that they had rotated around the fact that they needed to have really targeted ways of delivering code in a continuous and a fully automated way, okay? And so as we walk through the solution that they developed around Salt, it's really slick. Because what they did is, inside of Salt, you've got a master server that is a central controller for an infrastructure. And then we have agents that we put out in the infrastructure, we call them minions. And this is a classic topology for Salt. Now, I'm probably not going to be able to talk about topologies today, that's a whole other subject. We can do agentless stuff over SSH. We can build tiers. There's lots of things that can be done. But anyway, what they did is they set it up so that there's a master and they've got minions. On one of their minions is their Jenkins server. So they're doing continuous builds on Jenkins. Now, they then use Salt's peer communication system. So as soon as a build finishes on Jenkins, it contacts the Salt master. And it says to the Salt master, we have a new build that is ready to be deployed. Execute a routine that's going to deploy this build on these servers. All of this is done with a very, very small amount of code. It's something called Git deploy that you can go look up online. And send that information back up to Salt master. Depending on what the build was, it sends different arguments to this Git deploy runner, as it's called. That routine subsequently communicates down to those systems that need to deploy, and they run the deployment. So that chain, entirely automated. Now the next step where we look at how Salt is running through this process is that it sends the information up to the master, communicates down to the minions to say deploy code, but Salt's remote execution system that it's using now to communicate down to those minions is an entirely asynchronous system. And so the end result here is that when you send a command down and then get information back, since it's async, we can very easily redirect it to wherever we want to. It doesn't even need to come back to the source per se. And so Wikimedia has the results of these code deployments get redirected to a Redis database. And then that Redis database becomes the data backend for their internal UI. The end result being that they have their own internal UI that is directly now integrated with their continuous deployment with Salt. And that UI gives them an accurate representation of everything that's going on inside of their continuous code deployment system that's backed by Salt and Git and Jenkins and Redis. Now this was a really early deployment of this model, and I like using it because it's Wikimedia, I think that's cool. But there's a lot of other people who have augmented this model for using Salt for continuous code deployment and a number of other tools. So far more than just Jenkins out there that people are using to build code, of course. Despite the fact that Jenkins is freaking awesome. There are some of the guys out there. We build bots cool, and Bamboo exists. Bamboo's cool. Atlassian, you're cool. Sorry. Camera. Now, some of the newer deployments of this model with Salt focus around something that didn't exist in Salt when Wikimedia first deployed this, and that was Salt's reactor. So I've mentioned master and minions. Well, every time we're sending communications back and forth, there are event buses. And events are being fired on the master and they're being fired on minions. And so you can listen to this event bus and then run subsequent routines with it. Now the end result of that is that if we look at the Openstack development infrastructure, what they're doing now is that their Jenkins server fires an event off to the Salt Master. And then in the Salt Master, we've got this thing called a reactor that is made to react to events. It's not made to cause nuclear problems. Although I'm sure misconfigured, most I think they can cause problems. Now, this reactor then is able to listen to specific events that are coming up in Jenkins and do the same thing. Execute routines on minions that then tell them to deploy code which is available on Jenkins. So that's primarily the model that people are using now. It's much, much smoother. Now when it comes to actually telling systems to deploy code, we've seen a ton of different ways of doing this. Now Salt's own configuration management system can handle it very well and very easily. Or Salt's remote execution system has a vast library of one-off routines. So a lot of people will just call down to say, hey, Git or Mercurial or SVN or heaven knows what. Just update these repos and run a routine to deploy that code where I want it to instead of using Salt's higher level management systems. We do have people out there who use this environment with other configuration management tools. We run into this primarily because people discover Salt and they say, well, but I've already got a huge infrastructure with something else. And so they use Salt to automate other configuration management tools or tell them when to run, be able to pass those triggers in a very clean way. Okay. And then the results of those routines we've seen displayed in a number of ways. Halite is Salt's new web UI. And so there's a lot of ways that these events can be fired back and visible on the Halite web UI. By new, I mean very, very new and not necessarily pretty. It's functional at this point, but not pretty. I don't want any more crap about it not being pretty. Now, we're working on it. Okay. Now, must be tired. You said good at not laughing when the people laugh. So another thing that we're seeing a lot of use of is sending a data file about deployments back to Jenkins. And so Jenkins is able to then present information not only about the build, but information relative to that deployment. This is actually something really similar to how we're doing it at SaltStack for our own tests. See, I'm going to break out of the mold here, and something's going to break. Excellent. And so for, our own tests, what we do is we execute a test sequence. Yeah, I know. And it calls out to Salt Cloud, spins up a virtual machine on Rackspace, communicates with that virtual machine, and tells it to run the test, which allows us to very easily do cross-platform tests, which are obviously very important to a system that does configuration management. Okay. And then, of course, I already talked about tying it into external databases. This system where I'm talking about Salt's ability to communicate with Redis and dump data out there is a system we call returners, to say that we're returning information to a different location. And the returner system inside of Salt is made to attach to any arbitrary database or external data store or system. So we have returners that attach to Redis, Mongo, Cassandra, Postgres, MySQL. If there's ever any way to get Postgres guys to write code, it's that you add a feature for MySQL. And they get mad. You should see these guys. It's great. It's gotta be better. Okay. But we've also got returners for SMTP. So you can send something out that says that when this code deployment is done on these servers, I want it to send an email to somebody. If you've got 10,000 servers, that's not a very good returner to use. It's an email. But so it can attach to virtually any arbitrary external system. Okay. All right. So I'm going to jump ahead over to LinkedIn. I think that this is a really good juxtaposition between something like Wikimedia and then LinkedIn, because LinkedIn is a massive, non-virtualized bare metal deployment. They've got their big data tier, they've got web tiers, they've got databases, and it all runs on IAM. Whereas you look at Wikimedia, and they've become a very heavy, a very aggressive OpenStack organization. And they've got a lot of involvement there in OpenStack. But so LinkedIn was, they've actually given us now 2 major use cases. They started using Salt back in 2011, didn't tell me, otherwise I would have been quite scared, because I certainly didn't think it was ready for prime time. And they have, or for a long time, they're not anymore, but for a long time they were always our biggest deployment as they got up into the 30,000 server range. So the big things that we run into with LinkedIn as far as problems go is, yes, they've got the code deployment and configuration problem. They're continuously deploying updates to their websites. But this concept that they're developing around managing bare metal more like a cloud, where they've got disposable units in their cloud, or in their infrastructure. Sorry, it's not Verge, but whatever. Okay. And then this idea of fixing things that go wrong very quickly. That can be a real pain. I don't know if any of you have worked in extremely large infrastructures before, but if there's a single security update that needs to be passed out, that can be a cumbersome thing to do. Or if some disgruntled employee is leaving and you need to make sure that their user is taken care of, that can be a very cumbersome thing to do. Okay. And of course, consistency in their environment is very important, and there's a number of things that, I mean, they're a pretty serious shop. So they've become extremely reliant on Salt over the last 2 years. Because what's happened is they started deploying Salt early on when it didn't work very well, and started to build up runners in Salt, which are Python-based orchestration units. They would use these runners to then configure and deploy code inside of their infrastructure across one of their smaller tiers of about 5,000 systems in a development environment. Okay, and so this runner system that they started using, they deployed before Salt had config management in it. And more recently, they came back and they said, hey, now we've got config management in Salt, and they've come through and they've rewritten how all of their code deployments and code management and server setup works using Salt's config management system, which these guys are going to show you a lot more of in direct depth. Again, it's these rooms where there's no clock in the back. You know? All right. So, one of my favorite examples, though, about LinkedIn has to do with their ability to react to problems using Salt. So, if you remember the Java leap second bug that happened sometime last year, I love the story that we got out of LinkedIn. That they were sitting in a meeting and they were saying, okay, what are we going to do? How are we going to update our systems? What is this going to look like? And going through that planning process. And then a guy in the back said, we're done. I ran a command on Salt, we're done. They're all updated. And they basically said, oh, well, there's 2 days of our lives we just got back, or more. And so the ability to just reach out and touch systems in parallel very, very quickly is, again, a very effective and a very useful thing to have in rolling out an infrastructure. Okay. So this last piece I'm going to talk about is really starting to bring things together, and it starts to look at some of the newer things that we're working on in Salt. Again, this has been a very rapid presentation. But this idea of auto-scaling is really just a small piece of what I want to talk about. We were approached by a very large company whose logo is blue, to help them with one of their customers with respect to building an auto-scaling system, because for whatever reason they couldn't use anything else. And they came to us and said, we think that you guys have the pieces to pull this off. And we responded, well, yeah, I mean, we didn't think we'd be there for a little while longer, but they wanted to accelerate the process. And so I talked briefly about this reactor concept and about runners and orchestration units and running arbitrary commands. Okay. I haven't let it ring long enough. I always get to see who the nerds are if they can tell if that's what that sounds from. There's a smile. What does that sound?
It's the TARDIS.
There we go. Okay. Now, if you're going to get distracted, you got to make the most of it. So what we ran into with this system is they were already using somebody else for config management. They set up a Salt master, so they've got this reactor system in the event bus inside of Salt. We set up a runner that regularly pings the infrastructure to gather pertinent data about autoscaling. The nice thing about a Salt's remote execution system is that it really doesn't matter how big the infrastructure is. We can gather data from 5 servers or 20,000 servers very, very quickly and very efficiently. And so it's pinging the infrastructure and gathering this data, crunching it and making a decision to say, are we going to spin up more VMs or not inside of this reactor unit? So we looked at that and we said, well, that's all fine and good, it works. But we were far from satisfied on its capability. We had to build a target system for a target use case to be able to make these logical decisions. And we realized very quickly that the only way to handle this intelligently in the long run is to make a generic system for decision making. And so one of the Skunkworks projects that we've been working on, and we've been working on in conjunction actually with some autonomous robotics guys who have been doing work for the Navy. And we are about to open source this library, but it's a autonomous decision-making robotic library that's able to then listen to multiple events that are coming in, configure and hold on to those events inside of a state machine, and then make a decision based on those events. So instead of going out and saying, all right, we're going to just check the load every 10 seconds and see if it's high, well, and check how many Apache connections there are, we're able to actively listen to information coming back from all of the disparate parts of a given infrastructure. We're able to combine that information together to make a state, and then start to make more complicated decisions around it, around looking at things and saying, hey, we've got, say we've got a web tier, it's got 30 systems in it, say we've got our database tier, say there's an AMQP broker, or heaven knows, a number of other components. Instead of just looking at it and saying the load is going up on our web servers, we're able to say the load is going up on our web servers, but maybe our connections to them are down. Does that mean that we're dealing with I/O weight someplace else? We're able to start to look at it and realize that, the real way to mitigate this isn't just to spin up more of these web tier VMs, it's to balloon out the resources to our database. The real way to mitigate this is to address a different part of the infrastructure or address what we have in a different way. Similarly, what we're looking at being able to do is look at it and say, what's the state of our web tier? Okay, the right thing to do, instead of just spinning up more of these VMs, is to change the type of virtual machines that are being spun up so that they can handle the profile that we're currently dealing with inside of those connections and make those sorts of decisions dynamically. And so this is the thing that we're really excited about, that we're coming out with. We're going to be releasing this as beta in the next release of Salt, which again is something that we're very excited about. We've worked very hard to maintain a reputation of coming out with ridiculous new things on a really regular basis. So for instance, we just came out on the last version of Salt with the ability to have agentless systems out there instead of having to always have an agent running. So everyone here is fast. You know, it takes like 3 seconds to communicate with 100 servers. It's just not okay. It's too slow. But those systems are out there now, and we're able to keep pushing the envelope as to what it is that we do, and that's what we do. So we're really excited about what's coming up next. Let's see. Is that all I've got? Well, that's good because I'm out of time. Now, I actually talked ahead to this slide. I didn't click it because I probably wasn't paying attention. But we've got some of those basic routines in here that I was talking about. But yeah, in the end, again, very quick presentation, but in the end, what I'm trying to explain is that the real building of clouds goes well beyond these four-letter AAS acronyms, of course. It goes well beyond just the fabric that you need when you're setting up that infrastructure. And a lot of what we're trying to do, and a lot of what we're working towards doing, and a lot of what we have accomplished, rotates around combining problem sets on both ends. Because if you can solve problem sets up on a high level and have that integrate with your deployment systems, then you can really smooth out how a lot of this works at the end of the day. And so, hopefully, I mean, I've showed a few things that are helpful. I still think that these guys are going to give a more insightful presentation, and they're far better looking than me. But yeah, that's the gist of it. Any questions, comments? I don't want arguments. I'm tired. No, any questions? Yes.
So how does the Wikimedia web UI relate to Halide? So would this be, can this also be implemented with Halide so they do not have to write their own web UI and stuff?
We're working towards that, yes. Right now, Halide is primarily geared towards visualizing the event stream that happens on the master and interpreting commands that are executed through the remote execution system and tracking them. So you can fire off remote X commands via Halide. The next things that we're working on are heavily around the config management system and expressing that in Halide. And the cool thing about Halide is that it's detached and entirely event-driven. So when events come back into it, it doesn't care if they were fired from the UI. They'll just display them. So all of these automated events will still float up to the surface. But yeah, that's something that's in the works. Most of what we have now are bones in that regard. Thank you. Anything else? Yes?
To how many servers did you scale this remote execution part?
The largest installation that we've got is up in, where are those guys at? I mean, it's up around 70. LinkedIn's around 30,000.
And they all connect to the same 0MQ?
The largest single master deployment that we have in production is around 20. Generally, when you've got a larger deployment like that, you set up a system which we refer to as Syndics, which is short for syndicated. And so you set up multiple masters, and then they tie into a higher level master, and they replay the event bus back up to that master, and then replay commands down through the lower layers. So you're able to tier it out logically that way. Which we've also found is much more common relative to how people are physically dealing with servers. We've found it fairly rare. It happens, I'm not going to deny that by any means, but it's generally rare that you see many tens of thousands of servers in a single data center. A lot of deployments have them spread out, and those sorts of arrangements really help to have multi-data center management as well. Excuse me. But yeah, it's tens of thousands. Okay, any other? Yes?
I may feel silly asking this, especially because I don't come from the tens of thousands.
Oh, you check out. You've got Nintendo on your T-shirt. You've already won.
I'll show you my wallet later. But, no, but I'm an assistant engineer. I work in a few locations, and I'm new to the company I'm with. And like I have a couple places I'm supporting, and they have about 50 to 70 Mac laptops. Do you think I could use Salt for something like that? Because they don't have a centralized system. Or is that something that is used too out there for something so small?
Yeah, we've got quite a few people using Salt for laptop use. So we do have pretty darn good Mac support, and I'm trying to think of the best solution there, because I'm more trying to remember what a lot of guys have done. Because really it boils down to the fact that they're not always connected, and they don't need you to always be connected by any means. Salt's made to be really arbitrary in the way that it's communicating with systems. So
It's not overkill.
oh, it's not overkill by any means. Salt's made to be very lightweight. It's made to be able to drop into very small deployments very, very easily, and it's made to be very easy to set up and manage and maintain. So it's by no means overkill. Well, you're new to a fantastic place. System management is fun. Okay, any others, or should I hand over to our guys from Rackspace here? All right, gents, I believe the floor belongs to you.
While he's plugging in, maybe I can just introduce us a little bit. So my name is Oster. Jason's plugging in the laptop right now. That's Jason Swindle.
Yep.
And then Bruce Stringer is the other presenter with us tonight. There's a light on my face. All three of us are going to be presenting about a little application that we're working with. We're all Rackspace employees, DevOps team on Rackspace. Me and Bruce are the main developers on the team, with Swindle being sort of our configuration management guy. So we're going to talk a little bit about Grafitti, which is our internal application that our team has built. Rags to riches, the story, because it went from very small to very big. And I apologize if my voice is a little hoarse, getting over a cold. So if you can't hear me, raise your hand and I'll try to talk louder. Okay, so if you want to go to the next slide. Sure. So yeah, so this is a little bit about what we stepped into. Probably a lot of those are familiar to most of you guys. So it's really talking about how the application came about. It started out as this very small one-line command line script, as most things often do. And when we all got together, we realized this really needed to be something bigger. We needed to be able to have better controls over it. So it bloomed into this actual full-fledged web application. From there, we got buy-in from different leaders and different departments. We got a much bigger user base. It kept growing, and so with that, our scope needed to change. It's an internal application, so we're not going to bore you with the details of what it is or what it does, but we are going to talk about the technologies that we use to implement it, and how we were able to kind of scale that from this very little small thing that we thought up within a day to this system that was really robust and was very hard to take down, right? So things we're going to talk about, it's a Django application, so it's Python based. We're using currently Postgres as the back end, Nginx and UWSGI as a front end. We'll talk more about those later. But basically we went from something very small to something that kind of got thrown into the wild, and feature requests started coming in and scope started to grow because it was a very open-ended project. So that's kind of what we're going to talk about, and we're going to kind of take you through our hurdles of scaling and kind of how we stumbled through those, the technologies we decided to use, sticking with as much open source as possible, and the benefits and different ways we found of solving some of the problems. So we want to go to the next slide.
So, as Alan was saying, we kind of had this initial project that was very small, and it was very open-ended, so we kind of could experiment with what we wanted to do with it, but we did have an end goal. We knew that these two guys are going to be down in San Antonio, and I'm from Austin, so we had people working from different locations. While we commuted back and forth, we had people working on code from all over the world, both in Texas, but We had people from different locations. So ultimately what happened is we wanted to start with source control from the beginning so we could all be working on different things and pull them back in. So with source control, we're using Git, so we could leverage a couple different things in it. We could have feature branches, so we could have Alan working on something with the UI, and I could be working on something with Celery or some SHQ or something like that. And we wouldn't be fighting with each other on who's doing this, the development now, who's breaking what. I can break my stuff, he can break his stuff, and everybody's happy. Going on with that, you also need a workflow to go with your source control. You can't just all be committing to the same repository, because if you're still working from the same code base, you're going to have some problems. So the one that we ended up going with was the Git Flow Workflow. So that is kind of a modified feature branch workflow. So instead of just having your master branch, your dev branch, and just going from there, what we would do is we have a dev branch, and then as we work on different projects, we break it off into a specific feature branch. Like I said, I might be working on something with Celery, Alan's working on something with UI, or just something along those lines. As we rolled development servers up, we check out these specific branches, and we could just switch between them very easily. As we found, okay, good, this is ready to go, we merge those up into our development branch, move that to staging, make sure everything's looking good. When everything's approved, everything's looking good, we're going to tag that with a specific version number, and then production's always going to check out a specific tag. So there's no surprises in production, but we can always kind of go from there and say, staging has this, and we can switch back and forth with really no effort on our part.
So use what works. That's sort of just common sense a lot. When we first started, we just bootstrapped it as quick as we could. We stood up an Apache, MySQL, and just went with it. But as you grow and you start testing, you might find, well, that may not work what we want. So as he mentioned, they both mentioned, it's a Django application. So I started researching around what other options are out there. And I've always been a fan of Nginx. So placed that in, made a branch for it, implemented it, and just wailed on it. But of course, Nginx doesn't have a mod WGSI. Mod WGSI is Apache. So there had to be something that glued them together. So I researched around, played with different things, ultimately came out and used UWGSI, or UWSI, however you wish to pronounce it. But because we're defining our code, our infrastructure as code, and version controlling it and doing branches and tags and everything, changing from Apache to Nginx was really straightforward. And it's really cool to be able to go, okay, here's something broken, we fix it, pull it in. Just continue to do like they're doing. And all of this is easy to do with
configuration management, so like you're talking about. So we kind of led into that. Basically, we use SaltStack, right? We decided to use SaltStack because it fit our needs. We needed a way to deploy, like what Jason was talking about, different applications, test out new things we wanted to try, see what was working best for our scale, for our technologies that we were implementing. And we needed a way to do that. There's only 3 of us. If we were devoting one whole person to just building servers for us and sitting there and typing configuration files and making sure everything worked pretty and did that, that would be that person's full-time job, and he wouldn't be able to work on new features, right? So the most optimal way to do this was using something for configuration management. It made sense for us, especially for a small team, but it really makes sense for a lot of people, as Thomas was bringing out, even the big guys. Using configuration management like this meant we could follow that same workflow that Bruce talked about in our code with our infrastructure, right? We could keep everything versioned, we could keep everything branched. Our source control, the way our servers were built was versioned, tagged, it was released, and it was easy to follow. So with this, we were able to spin up not only dev, staging, production environments quickly, efficiently, without us being bogged down with that menial tasks of having to actually configure everything by hand every time, over and over again. We wanted to keep it that dry methodology, right? And just spin things up one time, save that configuration, move on with our lives, get features out there. So that's really why we went with configuration management. In particular, we went with Salt because it fit what we were doing. We're Python shop, it was a Python framework, so it made sense. We could understand the code, and we could keep going with it. It used YAML for its configuration files, right? That made sense for us as well. It's simple to read, easy to learn, 2 spaces and a dash. It's not hard, and it was easy to read. It was almost self-documenting, so it was one of those things we could kind of get up and running really fast. even for somebody who was brand new to configuration management. It also used Jinja for a lot of its configuration files, and that was something that Django also used in its template files. So the two meshed really well. We knew Jinja. We could use that same logic both places. That meant that using Salt in our deployment was super simple and super easy to plug in. We pretty much knew everything about Salt the moment we started deploying with it. So it made it worlds of difference for us and prevented us from having to actually ever log into a server to deploy anything. So it made it really nice. Move to the next slide. This is a simple sort of example of one of those YAML files. You can see it's pretty straightforward, easy to read. You can probably, most of you, read over it and understand basically what's going on. But it's just the Nginx install portion of it. That first line is just defining the name of this part of the configuration. Then we're setting up a repo for Ubuntu to actually pull this package from on that second line. The third line is actually where we're naming that PPA since we're deploying on Ubuntu. And that's just pulling from the Nginx-stable repository. That way we would deploy the latest version of Nginx. We don't have to worry about in our code which version number did we use. We're just pulling down the latest. We're also doing the next line there is the package install. We're actually getting Nginx. We're installing Nginx-extras because it had all the nice features we liked. But we're also requiring that the package repo be set up from Nginx install. So there's not an order conflict there, right? We're making sure that we implicitly say, okay, this has to have the repo before you can actually install Nginx. And then the truncated part here is where we do all the rest of the pre-stuff, such as setting it up as a service and making sure the upstart script's in there and configured right and all that jazzy stuff that wouldn't fit on a slide deck. So we just truncate.
Yeah, our salt methods. In the beginning, salt has many different ways of matching something, say the minion. So, for example, you can do qualified domain names, grains. The list is very extensive. Or you can make your own adventure and do it yourself. We went with grains. The reason being is the problem with a fully qualified domain name or just the host name, it can be edited. So you can edit in like Etsy host or just someone with elevated privileges suddenly just change the name of that node. And the next time a high state comes through, the scope of that server might change. Whoa, rogue server, you have a hunt for the Red October in your infrastructure. You don't want that. So the way we set up our grains is that when that node is created at that time, it's defined that. So that server can never be anything else. So we can't make a web into a Redis server, which is wonderful. The only way to get rid of it is to destroy it. So we don't have nodes going rogue, but it also allows us to really, really complement the way we do high states, basically bring nodes into alignment so we can configure, we can really make all of our configs dry or don't repeat yourself. So you can just match one time and it goes. We use a thing called Salt Cloud. It basically interfaces with cloud providers. So being that we work at Rackspace, we just use the Openstack provider on Salt Cloud. We tell Salt Cloud inside of a thing called a salt map, basically defines what your nodes are. Do this. And our nodes appear really, really quickly. A lot of times we can build nodes in about 4 minutes, and they will all build in parallel. And we also have a auto-configuring of nodes. So a webhead will be able to talk to another node, and they'll self-configure. You don't have to get involved or write huge amounts of code. Actually, Bruce will be covering that later about how that magic works. An example of one of the map files is right here. So first we define the provider. We call it Openstack. And then we just say what size server we're going to build. So it's an Openstack server. We just put a name there just for human sake because you're going to have a server list and they're just all random gobbledygook. It's not really good for humans. So that first line is not really needed. Next, we define what version of Salt we're going to have. So we're hard-coded to a certain thing so we don't deploy and get an explosion out of nowhere that we don't know. Then we set our grains. So we set environment. We use New Relic. So we set a certain variable there. What data center and what node type it is. So all these different things really build in towards the magic. And then the very first command you see there, that is literally building our environment. So when we run that one command, 5 nodes all come up at the same time. They all get created, and then the next command brings all the nodes in line to make them work. So we can go from 0 having no nodes to that sometimes in as short as 8 minutes to sometimes 20 minutes, barring, there's no failures of mirrors and Pip is not having a bad day. Something that we can't ever control gets in our way. But yeah, it's pretty freaking awesome. And also too, if for some reason one of your nodes just dies, the map file will only do the difference of what's missing. So when you run that map file, it's just not going to suddenly duplicate everything. It's only going to give you what you may be missing, which is pretty cool. So if I broke the Redis server for some reason, blow it away, run it again, they may never notice.
So, and just one thing to touch on, you notice here, we're pretty much just describing our infrastructure a little bit, on what it looks like. We're committing our infrastructure as code. So this is an example of where we're showing we have our infrastructure as code in a Git repository. This is what our infrastructure looks like. If we change that, we can commit that, we can make branches from there. So I can have a dev branch that has a different topology than the master branch, but we can all keep that under Git and move forward. We can iterate the script arm so it's using a different version of Salt in our development platform, so on and so forth. And so, going back to Git, so you have these projects that have all of your code in them, right? But there's definitely some information that you don't want to show to other people. Even internally, we have an internal project. We don't want to be releasing our database password, our username, API keys, all that fun stuff with everybody else in the company. So what do? You obviously want as much of your code is exposed as possible so people can see what you're doing, they can reuse it, they can help find bugs. The code itself is open, but you have bits and pieces of information that you don't want them to see. So where are you going to put this bits and pieces of sensitive data? Well, Salt does come with this idea of pillar. So you can make parameters out of just about anything and then reference that bits of information within your config files for Salt. So what we did was we made a submodule in Git and then made that private. So we had all of our code that describes how we configure our servers in one, and then a private that just had all of our password keys, API keys in another. So if you wanted to see how we did things, you had full access to that. If you wanted to clone it down and then replace those keys with your own stuff, you could deploy our app however you wanted. So we leveraged Pillar to pull all this information out, keep it secret, but let everybody see how we're doing these things.
Best practice.
So going on that, so you have all these different applications that have best practices and how you're supposed to do these things. So as an example, Django. When you're configuring that, one of the old best practices was to take these configuration options and put them in a local settings.py. That's not going to be committed to source code. It's going to live separately. But it does have code that's required to run. So you can see how problems would occur there, where if Alan's working on something and I'm working on something, he might have a typo, and it's going to be hard to troubleshoot. So instead, what you want to do is move to the new one where you have environment variables. The code is agnostic to all these little pillar options, and all you do is pull out these little bits and pieces on the fly as you need them. You set them as environment variables, so all of your code is exactly the same, and you just pull out these from the environment. Unfortunately, and fortunately at the same time, a lot of these other technologies that we've implemented strip environment variables. You don't want to have all your environment variables exposed to all of your applications. That seems kind of silly. So what we ended up having to do was re-specify those in UWSGI, in Nginx, in Celery, so they could run appropriately. They had the correct access to the databases. They had the correct API keys to access remote resources. But luckily, since we were using Salt, we could pull those same values from Pillar and drop those in. So they were all called exactly the same way. We only had to update them in one location in the Pillar submodule in Git, and then it would be reflected in all of them from then on. Granted, if we wanted to add any new arguments, we have to go through, add it to Celery, add it to the environment, add it to UWSGI, but it did make our life easier.
Yeah, so I apologize we didn't have any like examples of how pillar works, but it's basically just a key value pairing in there. But we can get into that later if you guys want to. This is a kind of generic outline of how maybe somebody's infrastructure might be set up. Pretty simple here. Single load balancer, 2 webheads, maybe some sort of like shared Redis server for caching or whatever have you. 2 database servers running Postgres and a backup server here. We have a backup server just pointing to the Postgres database because, hey, your application's in code, why back that up? The application is deployed and the only thing changing is the actual data in the database. So that's the only thing that needs to be backed up. So an infrastructure like this, if you were to go and deploy this by hand, that would obviously take quite a bit of time. Standing something up like this, using configuration management from nothing to completely this, we do it in under 20 minutes, everything working in the site online. Usually it's much faster than that. We say under 20 minutes because that's the high end. That takes no fail. But yeah, so this sort of example is very easy to achieve, and if we had to do this time and time again as we tested new things, we would never get features done. We're going to go to the next slide.
Sure.
So yeah, so talking about that, we try to be as infrastructure agnostic as possible, and doing that with configuration management, and especially with Salt Cloud built into all of that and working so well together, we can set up Salt Cloud to speak to multiple providers, which means we can set up on a public Openstack install as well as a local Openstack install. So maybe I want to deploy dev on my box sitting on my desk right here. No problem, I just tell Salt where to deploy it, and that whole infrastructure you just saw gets deployed right here. Maybe I want to test out 3 different DCs and we'll see which one performs, better. I deploy it, 20 minutes later, I'm testing those 3 different DCs, tear down the ones I didn't like, and keep with the one I did like. Or maybe, you need to move workloads. You want to test out a new provider, anything like that. Using things like Salt Cloud, which are pretty provider agnostic, and you can plug into almost anyone you want, and keeping all of your infrastructure in source code version, keeping your code in source code and version, means that your deployment process is dead simple. Anybody can do it. You don't have to be, a Linux guru. You don't have to be on every server checking everything. You just deploy it. Server misbehaves, destroy it, start again. So all this stuff makes us very portable and very repeatable. We don't have to mess with these I keep saying that word, but I can't say it at all. Tedious tasks, and instead we get to actually do the stuff we like to do, which is code new features, test out new technologies, see what's working better, what works best, these sort of things. We don't have to spend our time on just setting up the same old thing over and over again. So that's what we really like and enjoy about using Salt and the different open source technologies that we have been able to implement.
So this is going to be kind of a more technical example of where we're using Salt in the configuration file. And for those of you not familiar, I should go over the idea of grains real quick. They're little bits and pieces of information that you can pull back from the server or use to describe the server. They're going to be immutable once you set them. So as an example, we're setting environments, data centers, stuff like that for the server upon being provisioned. So for those of you familiar with Postgres, right, we have to set up the pga.hba.conf. This is more or less an ACL to say who's allowed to talk to me under what user, what authentication method is it going to use. And if you're using 5 servers, 500 servers, this task can be quite annoying. With that, we're deploying cloud. So we don't want to just give it a range of IPs. I don't know who's going to be on that range with me, so I have to give it /32s. So I have to know exactly what my server's IPs are going to be to deploy, and say, okay, this person's allowed to connect, this person's allowed to connect, and this person's allowed to connect. And then with that, I kind of go forward and configure it. So to step through what we're doing here, and for those of you familiar with Jinja, so we're going to set a variable to go through this template. So I'm going to set self-env. So it's going to go to grains and say, what's my environment? We set that during the provision, which you saw in that map file. So this one might be dev. So we now have variable dev based on what this current server is. Then we set self-DC on grains data center. So during provisioning, we said, okay, this one's in Dallas. So the data center is set in Dallas. So now we know this particular server is in Dallas and is in our development deployment. Now, what we're going to do is set up a WCS, which stands for Web Compound String. So we're going to generate a compound string to match all of our different minions and figure out who do we need to talk to here, right? So in this case, we're saying, find me all the minions in my infrastructure that have no type of web, that are in the environment that is the same that I'm currently in, and all of the ones that are in the same data center as me. This way we can have a deployment in Chicago, Dallas, Washington, Japan, and they're all going to be separate. They don't have to communicate. We can code them in to communicate if we wanted to, but generally when we're pulling these things up, we can put them out separately. Now, since we are talking about Python here, we're going to get all that information back and then generate a for loop. So we're going to have some sort of list that we can iterate across. So we're using salt's publish.publish here. So what this is essentially saying is, hey, all of you other minions, and no, this is the Postgres server that's doing this. So this is a server that we stood up, this is the master. And it's going to go out and find other things based on what the topology of our infrastructure currently looks like. I'm not hard coding anything here, this is based on whatever it happens to be at this specific setting. So all of you other minions that match these attributes, who are web, who are in my data center, or who are in my current environment, give me your IP address for Ethernet 0, and that's going to return a dictionary. We don't really care about the keys, so we're just going to do dot values like we would in Python and generate a list of all these IP addresses. Now from there, we're just going to iterate across all of those and add a line in our configuration file for host all. So all these web servers are allowed to connect into the Postgres server on all different users to this specific IP address using the password method. So now this one config, whether we have one server or 500 servers, is going to operate exactly the same way. If some server falls over the face of the earth and we high state, which is bringing everything back into the correct state based on our configuration files, it's going to generate that config file from whatever our infrastructure looks like. If we add 5 new servers and run this command, you're going to see 5 new IPs appear at the bottom. Also, if one disappears, like I said, it's going to disappear out of here, so you don't end up with stale IPs in these config files either. So operating in the cloud, we recycle IPs. So ultimately, if you destroy a server, you don't want those IPs sitting in there and having somebody giving somebody the ability to access your server again.
All right, monitor all the things. I'm quite fond of data. The more data, the better, because then you can choose to discard things. So on every kit, we installed New Relic to be able to monitor what the server is doing. Also inside of the app itself, pretty cool, check it out. But the real meat and potatoes, you could say, is every node is generating logs. That could be just from the kernel that's on the node to each application and on and on and on. And then if you're like our staff right now, it's at 5 nodes. But some people have 50 to 5,000 and keep adding zeros. That's a whole bunch of data that you might not know what's going on. So you may need to react because this over here is not happy. And you just lost contact with that one. Why? So with this logging system, you have a thing called Beaver. We chose Beaver because it's Python based, it's quite small in the memory. It takes all of your logs and ships them into Redis. And Redis just is our storage entity to store the logs. Then Logstash comes along and indexes them and gets them ready for Elasticsearch. And then Kibana is a really cool interface that shows right there that allows you to visualize your data. So no one would ever think logs to really colorful histograms, but it's really cool. So you could have in real time knowing what your Nginx is doing. So we configured our Nginx to output JSON. So Beaver just has to basically go, whoop, send the data over there. So you can see in real time if you're getting 200s or 500 or 404. So if we start seeing 500 errors pop up, whoa, what's happened? That's not cool. We might see that quicker than anyone else. Or you can set it up where if someone's trying to access Postgres, and Postgres starts complaining, hey, denied, denied, denied. We got someone in the system trying to do something that's not cool. Or anything that generates a log, even IRC. You can set up IRC to be in here. This example is from Mailgun. They have a really awesome article on Elasticsearch's website about how they use it for really awesome things. So check that out. It makes your data unbelievable. There is a little bit of work, but once you got it set up, don't want to ever go back to what you were doing.
So one of the things you'll notice when you're writing these larger apps is sometimes you'll want to rely on external systems, external APIs. Somebody's already done the work. You don't want to rewrite that code. There's some API out there that's going to make your life easier, but these don't always respond the way that you would expect them to in a timely manner, or maybe you have a piece of code that needs to execute and it takes a really long time. You don't care when it happens, it just needs to happen. So a use case for us, we had a form somebody was filling out, had to submit, and it had to go sync off with another external resource by an API. The user didn't have to wait for that to happen. They can go on about their day doing other things. So what do? We take those tests and move it to a message broker. Now you have this experience where they're filling out these forms, pop, they get a new one, they get a new one, they get a new one. It doesn't have to wait for these things to sync up. It doesn't have to wait for the database, right? It doesn't have to wait for all these different tests that could take a while or come back failed. They can keep doing what they're doing. They get a nice experience without the slowdown. So the way that we achieve that in our specific project is with Celery, and what that's going to do and what that allows us to do is connect to Redis and take specific tasks that we've defined in our Django project. So it's just going to be some function with a decorator saying, hey, this is a task. We can now specify this to happen and send it off to Redis. So we're syncing with this API. During the save process, just kick this off to our message broker, and that's going to go happen at some other point in time. They get a nice fresh response from the web server, they get a new form to fill out, and they don't get that slowdown anymore. So with that, you take these I/O blocking events, move them out, and you get a responsive front end to the user. So like I said, anything that's going to sit there and take up time that you don't necessarily care that it happens right this second, move off to your message broker and you can kind of keep going on.
Yeah, so that is mostly what our presentation was about. We didn't have a ton of time to dig into a lot of the stuff we very much probably could have and wanted to. So we skimmed the surface of a lot of this. So if you guys have questions about them, let us know. We're going to talk a little bit about what's next. So looking forward is always what we like to do. So we want to always make our config more generic. We're trying to make it more open, right? So we've got this great configuration management set up that can deploy Nginx, AWS CI, Django application using Postgres as the backend with Redis as a session cache and all this cool stuff going on. But then we have some specific stuff in there that really only makes sense for our application. We want to rip those out, put those somewhere that makes sense, and keep our config as generic as possible so that anybody can take that and deploy it and have a Django application spun up with all the nice things that we've been able to accomplish right out the door. So making it more generic is one of our main goals, so it's reusable, repeatable, and can be used by anybody who wants to pull it down. CI/CD is always a goal, so implementing things like Jenkins, which you saw a little bit about it, and doing that cool stuff. Autoscale is, of course, like Tom was talking about. We've always had our eye on that. We've been looking at Salt Reactor and using maybe something with Salt Mine in order to trigger those reactors in order to autoscale. So things like that are always the next steps for us. So yeah, that's kind of where we're taking it. We try to keep everything source controlled and try to keep everything through that same sort of open source technology platforms and going through that same process no matter what we do. Does anybody have any questions about any of the points we briefly got to touch on real quick? I saw that hand first.
How are you doing the coordination and orchestration in the full stack? So you have load balancer, say 3 web servers, Redis, and so you spin the whole thing new in pieces and can't stitch it?
It's all at once.
Yeah, so
how do you do the coordination based on the dependencies across node?
So basically the way it happens is we have that map file, right, we described, and that tells, in that map file we set this many web heads, this many database servers. We configure all the servers, how many and what they should be doing. When we spin up servers, we do that, Salt Cloud build that you saw, Swindle point 2, that sends API calls to build out each of those nodes and tells each of those nodes what grains they should have set, which tells them what role they're playing in our infrastructure. After they've all built, they all get high stated. So that's when Salt goes in and does actually the application, the actual configuration of everything.
So you code the stages in yourself?
We do requirements and things like that. So in Salt, it's got the sort of that required dependency chain set up. So anything that requires something else to happen first, we can either do a require in going forward or a required going backwards. So yeah, so we set all that stuff up in the code because we know what's going to need to happen.
And then based on, like, let's say you have a topology change, would you just like work that to the variant?
Yeah, so essentially, if we did have some sort of change that way, since we can deploy these things in just a couple of minutes, we fork it, figure out what works, how we have to deploy it, make the change, deploy it again a couple times, make sure everything runs as expected, and then we can commit it and then re-high state on our production system and then bring that in line.
Yeah, we use cloud for what it is. So we might have 2 stacks at the same time, but this one only took like 8 minutes to spin up. So we just move what's important, which is the data, destroy that, move on. So we don't treat the servers as pets or friends. They're commodities. So if it's not acting right, because it's defined in code, we just destroy it, start a new one. Or we're not quite liking the performance in one area, we spin up another, we get everything comfortable, DNS changed over, boom, destroy it. We just move around as need be to get the best end user experience, because that's what cloud is for, that flexible nebulous of your infrastructure can be anywhere or nowhere, however you wish to set it up. So if we have a big stack, but we know we're coming up to the weekend where no one's going to be using the application, we could spin down. And then suddenly we can see, oh, hey, it's Sunday, we might need to spin back up. So it's very flexible on that front.
One more. So then,
Sure.
talk about auto scale. So let's say it's a manual scale. You know, we have a web tier. And say we want to add 2 more to the web tier, and we want to add a Redis site.
Sure.
So is that like its own set of config runs, or are you altering the model for the whole system and reconverting the whole thing?
So yeah, essentially what would happen is that map file that you saw, that's just describing what our infrastructure looks like. So we're going to go in and then add a couple more web servers in there and then rerun that Salt Cloud with the map configuration option. It'll go out, look at all the minions that are out there, says, hey, I have web server 1 and 2 and you just specified 3, 4, and 5. I need to bring those up. Oh, it's node type web. So next time it high states, it knows how to deploy itself. And you saw that Postgres config and how we were auto adding stuff to the PGHBA. We can kind of do that in the reverse with the load balancers. So we can say, okay, we bring these new web servers online with Salt Cloud, and now we're going to high state. Now that load balancer is going to get its configuration updated to point to these new nodes as well. So it's just a matter of using that map file, updating it to what you want it to look like, high stating to bring it into alignment with all of your configuration, and bring it good.
Salt's also pretty intelligent. When it goes to high states, if it doesn't have to touch something, it doesn't. So if it's all installed, if it only touched Nginx during the high state, and Nginx is told reload if it's touched, it will. But everything else not touched, it just moves off. So it doesn't redo the whole node, it only touches what it needs to. So redeploys, especially like that, can go wicked fast.
So, yeah.
What if you deploy a new web server? How do you update your Postgres configuration in time? Because the web server won't work until you high state the database server, right?
Yeah, so right, we have the load balancer, right? So that's going to point to the different web servers, and then you have the Postgres. So the web server will come up, but it won't. Nobody's accessing it yet
Because the health check will fail.
The what?
The health check will fail.
Yeah. So essentially, what will happen is we bring this up. No, it's got nothing. The load balancer isn't pointing to it yet. It's just sitting out there. Then we run the high state. So the load balancer is going to get the correct IP in there to bring this to start generating traffic there, and the Postgres will get updated to start accepting.
At the same time.
Pretty much, yeah.
And this is a. Do you define cross-server dependencies? So do you define that Nginx depends on Postgres?
You can do that. You can. One of the things we do is like UWGSI won't start until the app's ready. But even if you're going to the whole server level, very meta, there's a thing called an overstate, where you can actually orchestrate that don't add the web until the Nginx is there. So you can actually even arrange things on the infrastructure deployment level. So if you know this piece has to be there even at the server level, not down in at the configuration level, you can arrange that. So it's immensely configurable, so you can really stack
That's
things.
a single node, right? Like you use the Python runtime, Nginx, those are all single nodes. I think you would ask cross node.
Yeah, that's what the overstate would be for. So you can say, this, don't run, or don't do until this is ready, at that real high up meta level. So we don't have to use overstates because all of our nodes usually are coming up at once, and all of them are built at the same time. But if we do find that chicken and egg scenario, we can use that overstate. I know they're always working on something different to get rid of overstates or just improve the way different things talk.
Well, we've got a much more powerful system than Overstate that we just released a beta on. Yeah, that works exceptionally well. It's got a lot more features in it. But yeah, you can create very easily. You can create macro level inter-server dependencies so that you know not to execute routines on certain servers. And the systems that they were showing, like the peer system in there, is smart enough to know to only configure systems that already exist, and you can build interdependencies that don't need to be controlled from a top level. So, for instance, you can configure it in such a way that whenever you update a single, say, a web system, as soon as that web system is done updating or somewhere during that path, you can send a notification out to the database servers telling them that they need to refresh their configuration so that it can be dynamically cross-configuring other components as well. It's really a question of what methodology is going to work for your infrastructure, because our goal is to deliver tools that solve problems. So you can orchestrate it from the top, or you can create live cross-dependencies that are happening via events and peer communication.
The cross dependencies, does it do like a partial converge, or does it rerun the whole definition for that node?
It can do either. Yeah, you can easily do partials or full runs.
Do you have anything to ensure convergence, or I mean, you can with that sort of cross dependency, you can wind up in a place where you flip flop right between different states.
No, you're very correct, and yeah, there are tools inside the phone where we're able to run extra routines that go back out and check the overall consistency of a system and can flag systems where updates need to occur.
Yeah, it's pretty cool. So like, for example, if I'm fiddling around in dev and I only made one change when I high state, it just touches that one thing. So my high state may take a second or two. But if it's a complete node build, it's going to do the whole thing. So it's quite awesome. That's all.
As far as I know, maybe my knowledge is limited. Before the node gets configured, salt has to be installed. Meaning has to be installed in that.
That's correct, but the newest version they just came out with is agentless. So all it would need is just SSH username and password. So get right in and communicate via the SSH layer.
So in your case, currently how does it work?
So currently we use minions. So with Salt Cloud, when it deploys a server, it automatically installs the minion and tells it who the master is. So we do that automatically every time we build a server.
So you use stock images. You don't customize animation with the minion installed.
I'm sorry?
You use Rackspace stock images.
Yeah.
Yes.
Yeah.
Yes, we use stock images. And then Salt Cloud. I'm
Do
sorry?
you use Cloud Init?
We do not.
We don't use Cloud Init yet.
Salt
no.
takes care of what we would use Salt.
But how do you deploy Salt?
Salt?
Do you want me to cover that?
Yeah.
Sure. Yeah, it's Salt
Okay.
Cloud.
So the Salt Cloud system, it goes out and primarily communicates with all these cloud APIs and triggers the building of a virtual machine. But part of the build process of Salt Cloud is that once the virtual machine is up, Salt Cloud connects into the virtual machine and installs the Salt agent for you. In that map file that they were showing, it had values in there that are pertinent to the configuration of Salt itself on the virtual machine that's being spun up. So you can pre-configure what Salt is going to look like when it is created using Salt Cloud. But so it just SSHs over and automates the full deployment of the agent.
I also have a question of if you have an auto-scaling system, if you integrate your infrastructure with an auto-scaling system, how would that system be able to integrate with Salt? Because from your because your infrastructure is completely defined in the Salt map, your launching or destruction or any of those changes in infrastructure has to be through Salt, because it knows that way it knows what is there and what is not there.
Yeah,
if something happens from outside, say from another system which is say an auto-scaling system which is managing yours, how would you integrate with Salt?
That's a good question. That's something we're soon to get to, but he's got something really cool.
Okay, so you've got a couple of options there. One is the question of how your auto-scaling system is working. If you want your auto-scaling system to tie into Salt's provisioning system, then it's easy to just say that at certain levels we're going to execute different maps. And so you can have a map for certain levels of escalation. It ensures that that view of the infrastructure exists. Similarly, with if you're using Salt's reactor, so that again the auto-scaling happens via Salt Cloud, then you can configure that to be much more dynamic as to how those updates are happening. Is that what you're asking?
I was asking, can Salt Cloud listen for, like you have reactors, so can it listen for events when a system is triggered by somebody else and react according to that?
So,
can it listen for, say, a new web tab get launched by another system and then automatically update its map or some kind of thing?
Oh, yeah. So the event bus inside of Salt is an open event bus. So what you can do is you've got a couple of options. One is you can have an external system that is tying into the event bus and firing events, and then the reactor can react to those events. Or, as you were saying, you can listen to them. So it's really easy to have Salt Cloud execute on a regular basis and query what's going on in your infrastructure and then make decisions based on that information, because Salt Cloud is able to not only provision systems but find out everything that's there and then compare it to what its current maps look like.
Right, so in this case Salt Cloud is the decision maker, what you're saying, where it decides whether to launch or not depending on the map. Can the map adjust depending on how the system is changed outside?
So in that case, you would still be using a Salt as a decision maker. So let's say you've got like RightScale or something like that deploying servers. Like he was saying, you could have Salt actually listening for changes in the environment, so new minions to start talking to it, and then you would still use Salt's reactor to react to that and create the map file accordingly. Yeah.
But yeah, the reactor can be configured to dynamically alter map files. The reactor can do virtually, I mean, it's an open-ended reactor. It can do whatever you want it to. Okay. You good?
Yes.
Okay.
Any others?
In terms of security, any plans implementing SE Linux or
It does.
Armor or anything like that?
It does interact with SE Linux, but again, he's more on that front.
Sure. Yeah, Salt can be used to manage SE Linux, and Salt can run on SE Linux enabled systems.
But it runs, doesn't really have a SE Linux configuration. It's pretty much like open to the whole system, right? The current state.
So this depends. Okay, this depends on your SE Linux configuration. It also depends on the context within SE Linux in which you're running the minion. So the minion itself is a system that has access to management on in your environment. Mm-hmm. Now, if you start up, and forgive me if my SE Linux is a bit rusty off the top of my head, it is a bit of a rabbit hole. But by default, you would start up a minion inside of the runtime, so it would be running under the context under the init context, and it has init context under root, etc. And it's got sufficient access to modify the system. Now, subsequently, if you wanted to run the minion and give it specific contexts to restrict what it's able to do, there's nothing that prevents you from being able to do that. Because fundamentally what Salt's doing is that it's got this library of remote execution routines that everything's based on top of. And if you restrict what those underlying functions are in your own, the term just left me. It's the SE Linux. Oh, this is embarrassing.
Context?
Sorry?
Context? Is that the word?
Well, I'm looking for the
role label and type.
well, how you define what those are in the
Policy.
Policy. Thank you. I would think that you would know. But yeah, if you define a policy that outlines what that minion can do, then the minion's routines will flat out fall down as you would expect them to, relative to the constraints that you gave it for SE Linux. So you can wrap policies around it that restrict its movements just fine. Is that what you're asking?
Yeah. I mean, it just seems a little bit difficult that you would do it on your own. I mean, as a developer, because you don't know what everybody else is doing, right?
Oh yeah, we're not developing a bunch of targeted SE Linux policies.
Okay.
That does get very hairy.
Yeah, because you got to target to whatever you want to do with it, right? And that's
Right.
what you want to limit. Currently, really, most of us are running like a minion that can really do anything to the system, right?
Right. And usually the way that people approach it is that they'll say they want a minion that doesn't have any right access to the system. They'll just run it as a non-privileged user, and then use it like as a monitoring minion or as a job management minion.
Okay.
That's a really common use case for high-performance compute
Okay.
deployments, for instance, because they end up using the minions. A lot of them, what they'll do is they'll have a minion running as root and then a minion running as a user that's actually executing all of the HPC jobs, and then the root minion is attached to a different master, and so it's got different controls, and the people running the jobs are elsewhere, and they've partitioned it that way.
Okay.
But so, yeah, there's a lot of options as to how to do it.
Cool. Well, that's all we have, so.
I've never had an SE Linux question. You're freaking awesome.
No, I really do like it. I think it's necessary to run everything, publicly.
Oh yeah.
And I'm
No, SE Linux is awesome. I'm genuinely just relieved to see somebody who's willing to deal with it and get it going. Because I wouldn't imagine running a ton of services publicly without SE Linux. I think it'd be insane.
You mentioned earlier that Salt also has the capability of monitoring all the infrastructure. So I'm kind of curious as to, what the capabilities of that are, and does it have also automation built in after that monitoring event triggers it, and brings the host back up or whatever.
Okay, so where we are right now with monitoring inside of Salt is that we've got the backend libraries that we need for gathering system information and monitoring. We've got all the scheduling and routine management systems that we need for monitoring. We've got the ability to interface with virtually any database to store long-term data, and we've got all the interfaces to query the data out of those databases. Really, at this point, the only thing that we're missing for monitoring, is a pretty interface. But yeah, we are able to have the monitoring system fire events on the bus, and then it's easy to go in and make reactor units that can react to those events. So that's all there. It's not quite as polished as it's going to be in the as it's going to be in the near future, but the bones are there, and we keep building on that. Is that what you're asking?
Yeah.
Okay, thank you.
Good. Yeah. I think that was all we had. We're going to stick around for a little bit, so if you guys want to mingle and chat about questions or things we could be doing better. We don't say where they end all be all by all means. So if you got suggestions for us, we'd love to hear it too. So yeah, that's pretty much it. I don't know if there's anything else left to talk about.